Good morning, AP Stats. It's what day is it? It's Monday, March 23rd, and this is Mr. Ellinger here. I'm just going to go straight to the content. The email should have all the information about changes to the AP and stuff like that. All right. Okay, here we go. So we're starting chapter 3, which begins with scatter plots. It's what we're looking at is we're looking at two variable quantitative information, which we haven't done before. So we've got two different variables. We measure them both quantitatively, and then what do we do with that? And so you're here's an example of the kinds of things that you're going to see. And we were going to do an activity where you come in and there's a bowl and there's a bunch of starburst in the bowl, and you get to reach in and see how many you can grab, and then we count how many you grab, and then we measure your hand. And unfortunately, we can't do that. I apologize that we can't do it. So here's the book's data, but it's a great activity and it's a good one because it gets the class rolling right away. And so here's a graph of it. And so first off, what is expected when you see a scatter plot? What should we see? The big thing is make sure that you label your axes. Always. And indicate units if appropriate. Just that's always a good thing to do. And then also scale your axes. You will notice though that they don't have to start at 0. For us in stats, we know that sometimes data values are really far from 0, so that's fine. So you don't have to start from 0, but you need the scale to be consistent all the way across, whatever your scale is. And then you just plot the points. And as long as they're reasonably close, then that's fine. Okay. Now, next thing says describe the association. This is something we always have with new data. We say, how do we describe it? What do we talk about? And there's a set of 4 things that you should talk about whenever you're looking at a scatter plot of data. And they say, describe what you see. One thing that you should describe is you should describe whether the direction of it, whether it's positive or negative association. Whether it's positive or negative association, positive going up, negative going down, or no association if it's just a kersplattle of stuff. You want to describe the form, which is mostly we're looking at, is it linear or is there a definite curve to it? Now, when we say linear, we don't mean literally linear. Like we'd look at this data right here and we'd be okay with calling that linear because it's just a general linear trend that it has, and there isn't an obvious curve to the trend. So don't think like an algebra class where it has to be in a perfectly straight line. Yeah? And then the next one, something that you wouldn't do in an algebra class either, is talk about the strength. How closely does it adhere to that pattern, whatever pattern it is that you see? So this thing's moderately strong, I mean, every time, not every time you go, you have a bigger hand, do you get more candy? But in general, it's pretty consistent that when you have a bigger hand, you get more candy, and there aren't too many exceptions to this rule. And so we'd call this, pretty strong. It's a definite positive association on this thing, a positive linear association. And the last thing, which isn't really relevant to this one, is you want to mention any outliers or unusual points. I mean, that's the catch-all. That's the catch-all at the end where we say, is there anything that talking about these things here doesn't cover? Something kind of strange that you want to mention about it. Okay. When we talk about outliers, what do we mean by outlier in this case? Because that can be a little bit interesting. An outlier is something that doesn't follow the pattern, whatever pattern we see. Follow the general trend. Okay. A couple of unusual notes about scatter plots. I went over this ahead of time and I thought about what my things were. A couple of unusual notes is one is we don't use independent and dependent relationships. We don't use those words because we don't want to talk about things being dependent because that's too cause and effect for us. So instead, I mean, it still suggests the same idea, but it's just not as forceful. We use explanatory, and explanatory because it has an X in it is the X, and response. which is where we'll put that on the y-axis. Okay. There is another unusual note, but I don't remember what it is right now. Okay, I'm gonna let it go. So there's just a little joke here. You can check it out. It's pretty funny. If you haven't checked out this website, it's good. It's got a lot of stats stuff in it, and it's pretty entertaining. All right. And in class, we might have gone over this one and asked you to describe this one. And so, what's the relationship? What do you see the relationship between sodium and fat in this graph? And I would say it's definitely a positive association. Generally, the general trend is definitely positive. I'm going to say it's generally linear, and it's pretty strong, but I gotta notice that there's these different groupings. These are for salads. I wonder if these are like specific kinds of salads, like these are their chicken salads, and these are their bacon salads or something like that. It looks to me like there's set groupings, and I wonder if it's super linear within each grouping. But that there's some difference between these things. Just the way the pattern looks, I kind of wonder about that, and I'd want to investigate it. That's what you need to know about scatter plots. It's not a big deal in terms of describing a scatter plot and how to make one, and that's pretty straightforward. And the book shows how to do that on the calculator. It's a little tricky. I might record a video at some point on how to do that because it's a little tricky, but the book does cover that, and I'll make sure to include that in the homework. So next, we have the question about correlation. Now, correlation is a word that's used in very general terms in common day language. There's a correlation between, amount of sleep I got and, how long I can pay attention to Mr. Ellinger. And we have, we use that word a lot, but sometimes we don't use it in a really specific way. And correlation is a vocab word for us, and it means a very specific thing. It's actually a number. Talk about that in a second. It's a number that you calculate, and it measures two things. One is it measures the direction. So it's a measurement that tells you about the direction of your scatter plot. And the other one it measures is the strength of the linear association. So some things to know about scatter plots about correlation about it. And it's a number that you'll calculate, and pretty much the calculator will do the calculating because it is kind of a long process. One thing is it has to be some number between -1 and 1. Always, always, always. So correlation, this thing they do, which we'll explain in a second, calculates out a number and says, your correlation is 0.5 or something like that. Okay? And if you're at 0, then that's no association. But keep in mind that's no linear association. We'll talk about that in a little bit. And if you're on the positive side, then you're a positive association. And if you're on the negative side, you're a negative association. And then the farther you go out from 0, the farther you go out from 0, then the stronger the association is. So this is stronger going out that way, and this is stronger going out this way. So a -1, if you had a correlation of -1, you're an incredibly strong, so adhering to the pattern, negative association. So that would be a bunch of points. Is this pointing the right way? Yeah, it looks like it is. Pointing, going down in a perfectly straight line. That'd be a correlation of -1. A correlation of 0.1 would be, there's a little bit of a positive-ishness to it that's going up, but it's really, really weak. Because 0.1 would be like there. So it's positive association, but just someone walking their dog. Positive association, but really, really weak and almost no association. You almost never get exactly 0 for an association. You might get like 0.01, and then it's like there's basically no association. All right, so here's a bunch of examples looking at these things, and you could say, what do you think the correlation is of this thing? And I'll give you a second. You can decide. You can pause, think about it. This one's going to be pretty close to 1 because it's darn close to a perfectly positive associate, really strong positive association, very linear. And so the only thing, this point's a little bit off, but I'm thinking this would be like 0.95 or something like that. This next one here, definite positive association, but it's a lot weaker because there's a lot more, there's a lot of spread around this thing. You can see there's some people that are way up here, and some people, and Albert Pujols is way down there because he doesn't strike out much. Apparently, I have no idea what this is about. And so this is me, more like a 0.1, 0.2 or something like that. It's a very weak positive association. Next one, this one. Please notice this one is definitely curved. And generally, when you have curved data, it's not even a good idea to use the correlation to measure it, because we're only trying to measure the linear association. And you look at this and you just say it's not linear. So we shouldn't be discussing correlation. Now, if you actually went and calculated it, it probably would be pretty good because it's a pretty strong association. You're really close to the line the whole time, and you're not missing by much. I'm guessing it would probably be like a 0.9 or something, but you shouldn't even, that's deceptive. You really shouldn't use correlation to measure this thing because it's curved. How are we doing on time? We're doing okay on time. So how is it actually calculated? And this is gonna, I'm gonna think about, yeah, this is good. I was just thinking about how far I want to go on this. So the way it's calculated is with this formula. It's adding up all the z's and x's, z's and y's, multiplied together, divided by, and then after that, dividing by n minus 1. And somehow that gives you a number between -1 and 1. I'll admit I never have studied the math of this to show that it would be between -1 and 1. Like how does that work? But it does. So what does that mean? So we'll think about, like, if I find the mean x, so I'm just kind of guesstimating. It looks like the mean x is about here. And the mean y, that's pretty balanced. Yeah, it looks like, I don't know, it looks like it's about there. So this is the average x. This is mu x and mu y. I know this is probably a sample. This is a sample, so I probably should be using x bar, but cut me some slack. Okay, so you'll be multiplying together the z-scores for x's and z-scores for y's. So take a look. Take a look at this one right here. This is going to have a really big z-score because it's like way the heck out there in the x direction. It's really big for the x's. And so its z-score for x's might be like 2 or something. And then if I look for the z-score for y's, it's high, but it's not quite as high. Maybe I get 1 or something. And then multiply those together. So 2 times 1, you get 2. And that would be for this one. So this one contributes 2 points. I'll say 2 points. And then take a look at like this one right here. This one right here, the z-score for x is, I don't know, about 0.7 or something maybe. I'm just kind of guessing. It'd be above average, but not that above average. And the z-score for y is, it's right on the axis. So the z-score for y is 0. So this thing is going to give you 0 points. And like one here, the z-score for x is about -0.7, negative 1 or something like that. And the z-score for y's is, I don't know, pretty small, like 0.2 or something like that. And so maybe this contributes, but notice that because one is positive, one is negative, then it contributes maybe, I'm just guessing a number, -0.2 or something like that. But remember, you'd want to, if you actually had to calculate it, you'd do it by hand. You never have to do it by hand. This is just for the idea. And then you'd add up. You do this for every single point and then add them all up. Or isn't it great that the calculator will do this for you? And then divide it by n minus 1. So if you think about it, anything down here is going to be positive because your z is negative in the x's and in y's. And when you multiply them together, you're going to get a positive number. And anything up here is going to be positive. And anything over here is going to be negative. And anything over here is going to be negative. And so when you're adding all these things up, if you have stuff in all the quadrants, then things are going to cancel each other out. So you're going to tend to get a smaller number closer to 0. If everything is in these two places, you're getting a lot of positive stuff. That's why you end up with a positive correlation. If you have lots of stuff up here and lots of stuff down here, then you're going to end up with a negative correlation. So that's just the way that it works, just understanding how the formula works. But there's a few things, and so we're going to have some examples showing the effect of this. This does some weird stuff. So what if you had a curve data like that? Oh, I'm not going to make it. I'm going to make another video. Sorry, I almost did it. So stand by. One more. It'll be pretty short.